Today I welcome you for this class 9 physics, force and laws of motion. In fact, there is one more, that is motion chapter, which has to be done before doing this force and laws of motion. If there is time, I will do that again later on. But if we start directly with chapter 2, this is chapter 2. This is chapter 2. Force and laws of motion. Now, first of all, we all know what is force in our day-to-day life. It is just a push or pull. That is how it is defined. Okay? Force means something has been done on other thing so that it is moving or it is changing its state. So that way we know. So in a general way, force is always known to us. But in physics, we need to define it properly. Force is a push or pull which tends or changes the state of rest or of uniform motion. This is how it is force introduced first. After that, force is a push or pull. I insist you write all these things. Push or pull which tends means tries, tends, or sometimes it is successful in its trial, tends to change the state of rest. Or of uniform motion. Very important is this rest and uniform motion. Okay, later on we'll know what is in detail that is. Okay, now more scientific definitions are also there that we will write after this. What is force is that when you apply force on anything, what will happen is it will change the state of rest. That means if it was not moving, here it is as it is, when you apply a force, it will move. This is the meaning, the state of the rest will change. Or it may happen that something is uniformly moving. That means it is changing distance in the same manner. When time passes, 5 minutes 10 kilometer, another 5 minutes 10 kilometer, another 5 10 kilometer, like that. Okay, same distance it is covering in every interval of time. Then if I apply the force, then that way of moving is changing. It will continue to move, but it will change the uniform motion. That is the two way of understanding the force. Now in detail we write it like this. Force can be defined as an external force. It is external, not from inside. Outside, it is from outside somewhere. It is applied effort which changes or tends to change the state of rest. Or speed or direction of motion of a moving body. Remember, body means object. In physics, body means anything. It can be point object, very small, very big. We call it body, not human body. Okay, moving the body means object. So this is the force. SI unit of force is Newton. Short form is right, capital N. another thing now is friction. In studying force, we also study friction. Friction is what? It is symbolized as small f. This was symbolized as capital F. Okay, force is capital F. Friction is small letter f. Friction is an obstruction to all kind of motion. What is friction? Friction is a obstruction, means something which disturbs. If something is happening, it is going to disturb, obstruct, opposite to all kind of motion. Suppose this motion is happening, my hands on this wall, this is moving, and because of the movement between the skin and this board, there is an opposing force along this direction. If I'm moving this way, something is opposing in way, this way. That is why the sound comes, and there is a kind of sensation which tries to stop my object. It acts like a brake. Okay, so that is called friction. Friction is an obstruction to all kind of motion. Whenever there is motion, it will walk. If there is no motion, it will not be visible, it will not be felt. Okay, no matter which direction the body moves, friction pulls it in the opposite direction. Okay, if we move body upward, the friction will walk downward. If we move downward, the friction will walk upward, like that. It will act in the opposite direction. In fact, friction is very important for having all these things done. Whenever we walk, if there is no friction, we will fall. We cannot write if there is no friction between the tip of this marker and the board. So all this friction is very important in everything that is happening around us. Most of the things, friction is helpful in carrying out those things in real. Okay. Friction necessary for the stability of the body. For example, to walk, you need to sit, you need friction, or climb also you need. If you want to climb, you need friction. No friction, you will not be able to do. Okay, this is the example of friction. Otherwise, you will slip. When you walk, you will slip. That is why you slip when there is no friction. Very, very smooth. Imagine a wall very, very smooth. You step it, you will fall. Okay, very, very smooth surface. How will you sit? You will fall left or right somewhere. Okay. Next is balanced and unbalanced force. The name itself that suggests balanced means what, and the unbalanced is what. Now, balanced force is those which do not change the state of rest or of motion of a body. Suppose there is one object, there are forces acting on them, but after all the forces are acting, even then it is not moving. That means those forces are balancing each other. So that is why it is called, those are called balanced force. Okay. An unbalanced force means if force is acting on anything but resulting into motion, is called balanced force, right? So we write it here. Suppose there is a table. book is kept here. Okay, book is kept on a table. You know the gravity will attract downward towards the ground, and the table pushes the book. This table also pushes the book upward like this. This is a classic example of balanced force. Here, this force is balanced by this, exactly opposite. So this is an example of balanced forces. Okay. Now, when it is in this condition, the table pushes it upward with some force, downward with the gravitational force. Now, in the same way, we can also understand friction pushes the book on the left side, and on the, let us assume that the weight is acting on the book in downward, and if the frictional force acting on the book is 5 Newton, then the book will be at rest. Suppose we apply force in this direction, this way, pushing, but between the book and the table, if there is a frictional force acting, and if there is exactly equal to the same force that with which I am pushing it here, then it will still remain in the balanced force. So that way, till that, the balanced force will be the example. Now, in this case, what we can do here is, this is weight downward. This type of force is called normal force, and the frictional force, I'll write it here. If we apply force in this direction, then this will be friction in this direction. Okay, so here we can write normal. Reaction is also a force. Okay, why it is called reaction? Because of the weight they're applying, that getting that normal reaction. Normal reaction is N is equal to weight W. And number 2, here at left and right, applied force. Suppose this is F, that will be equal to frictional force small. Okay, these are the things happening here in the example of balanced force. Okay, and there is no change in the motion, you can see. I have taken all the examples from the book so that when you read the book, you'll feel that all these things are given to you and in a easy manner. Okay. Next will be, suppose a vehicle is moving. Vehicle is moving in this direction. Okay. It has some velocity v. It is moving in that direction. Okay. Now, what happens? If a truck is moving with a constant velocity v on a road, it will continue to move with the same velocity if forces are balanced. If I apply some force, otherwise you can understand there is some force already acting downward, normal acting upward. If we apply, if you understand these forces are still acting, still it is moving in the same direction with the same way, no change in the velocity. That means this is also an example of balanced force if it is uniform. Okay, in the uniform balanced force. Now, balanced force is that which do not change the state of rest of a body. These are qualities of balanced force. It will not change the state of rest of the body. If it is not moving, it will not disturb, it will still remain rest, just like this example. Okay, and just like this example also, change the state of motion of a body. If a body moves with constant and uniform are same, constant velocity, it will continue. Move with same velocity. Okay, this is this example. In the case of balanced force, if it is already moving with uniform velocity, you apply balanced force, which is already there, this and this. Even if you apply some other force which is not making it change its velocity, then it is, you say there is a balanced force. Okay. Number 3, balanced force do not produce any acceleration. Means it will not speed up or it will not slow the motion. Uniform velocity will remain, and you will also not change the direction. Acceleration uniform will not be produced, means it cannot move faster, it cannot move slower. If it is not moving, it cannot move, and it cannot change the directions, initial directions. Can change the shape of the body. The last one is possible. Okay, it can change the shape of the body. You can give here an example, a squeezed up balloon, squeezed up in the textbook also. That example is given to you. Okay. Now this is about balanced force. Now for the unbalanced force, we will again try to understand with similar type of example. If you finish up this much, we come to unbalanced force. Okay, remember till now we finish force is a push and pull, which can change the state of motion of the body. After that, its units was Newton. Okay, symbol was capital F. Friction was the force which is always acting the direction opposite to direction of the motion. After that, balanced force. Balanced force is something which cannot change the state of the motion. If it is not moving, it will allow it to remain. If it is already moving with uniform velocity, we will let it continue like that. Okay. Now, in the second part of that, unbalanced force is also there. This remains. What is this? Let us get another, the same type of example. Table is there, book is there, the book suppose, or any other thing also you can consider, that is placed on there. You already know it will always act this one, it is always act here, normal. Okay, weight is downward, normal direction. Suppose we apply a force here, 10 Newton. Remember, this is F, and the frictional force is 5 Newton. Frictional force is here. Remember, frictional force is here between the two. Okay, that means what will happen? The book will move this way, right? Because when I apply the force, it is slightly more than the frictional force between the book and the table. Remember, when I applied 10 Newton of force, if it is more than 5 Newton, which is the frictional force between the book and the table, then it will move this way. This is a classic example of unbalanced force. Okay, here what happens? Number 1, normal reaction, that means N will be equal to weight, W, capital W, balance, no change. Number 2, applied force. This applied force, which is symbolized as capital F, is greater than, okay, is greater than what? Frictional force. So that is why it is winning it. So it is moving that way. This is the example of unbalanced force. Unbalanced force creates a rest object to move. Earlier, remember, it was not moving. When I applied this, more than this, then it started moving. This is an example of unbalanced force. Okay. What will happen to unbalanced force just like that if we want to write all the things about it? See, just opposite to the balanced force. Unbalanced force, what happens? The body at rest will start moving when you apply unbalanced force like this. Another thing can happen is that a body is also possible moving at constant speed gets accelerated or decelerated. That means either it will speed up, it will start, its speed will increase, or it will decrease. Just like in a vehicle, it is moving 40 km per hour, suddenly increase the speed. You apply the brake 40 km per hour, it stops slowly. Acceleration is increasing the speed, decelerated is decreasing the speed. Both is possible in unbalanced force. Unbalanced force can do two things. Object which is not moving, body which is not moving, it can make it move. Second thing also, it can also make one more thing, a body which is moving already with some constant speed, uniform speed, it can change its way of moving and it can make it speed up or slow down. Okay, so what is the next one is, in both the case you understand both are force we are studying. Okay, unbalanced or balanced, both are force. So force work is to change the state of the body, either it is at rest or of uniform. Okay, now next topic is resultant force. The name itself, resultant means final, total, net, that is the force. It is that single force acting on a body which produces the same effect or acceleration as produced by number of forces acting simultaneously. Now, to understand what is the meaning, suppose there is one object. Okay, one object is there, body is there. The meaning I am telling you, what is resultant force? Resultant force is, instead of applying many forces, 1, 2, 3, 4, if you have only one force and it is also working the same way, same effect it produces, that is called its resultant force. Suppose this object is here, I am applying one force this way, this way, this way, okay. This I call F1, F2, F3, maybe this way, F4, F5. Then its resultant is what? Resultant is this. Resultant is this. Suppose I have only one force, big force maybe or less force, that doesn't matter. So this is called here R is the resultant force which produces the same effect. As produced by F1, F2, F3, F4 and F5 together. Okay, so it may be 10, this may be 5, 10, 5, 10, 15, 20, like that. So this will cancel 0, this will somewhat cancel, and then whatever remains, the value is not important. Okay, final value will be R will also act in the same way that all these are acting. So F1, F2, F3, F4 resultant is this. I'm not saying that this will be F1, F2, F3, F4, F5. If you add up, it will give this. No. It may be added, it may be subtracted. Depends on the direction also, because this is vector quantity. Okay, we'll do it later in the other class also. So this way we finish the first part of it. After that, laws of motion will come. In laws of motion, we have first law, second law and third law, and then slowly we'll move.